Okay, class, in this lesson, you're going to learn to factor a polynomial by finding the greatest common factor, or GCF. So let's go ahead and get started with the first example. Okay, here we have the following polynomial, 12x to the fifth plus 8x to the fourth minus 6x cubed. So the first thing we're going to do is to apply the prime factorization of coefficient for each term. And what that means is we're going to factor each coefficient, so 12, 8, and negative 6, or in this case 6. We're going to not work with the negative numbers for now. I will show you how to do that in the next example. But we're going to factor each of these down to their prime numbers. Okay, so we're going to take the number 12, which is my first coefficient, and we're going to break that down to the factors 2 and 6. You could do that with 3 and 4. It really doesn't matter. It comes out to the same answer. So you'll see that the number 2 is a prime number, and that can not be factored any further. However, 6 is not a prime number, and that can actually be factored further down to 2 times 3. Okay, so if we bring this 2 down, we see that the prime factorization for 12 is 2 times 2 times 3. Okay, so let's work the next coefficient, and that is 8. 8 factors down to 2 times 4. 4 then factors down to 2 times 2. And if we bring this first 2 down, we see that the prime factorization for 8 is 2 times 2 times 2. Okay, and then lastly, we're going to take the number 6, and we're going to factor that down to 2 times 3. Both of those numbers are prime numbers, so they cannot be factored any further. Now that you've gotten the prime factorization for each of the coefficient, what you want to do is look for what is common across all three. Well, we see that we have a 2 here, we have a 2 here, and we have a 2 here. Okay, so I'm going to go ahead and circle that. We have a 2, and a 2, and a 2. So 2 is common across all three coefficients. We do have a 2 here, and we do have another 2 here, but there's not another 2, so that's not common across all three. And we have a 3 here, we have a 3 here, but we don't have a 3 for this coefficient, so that is not a factor. Okay, so step 2 is to do the same thing with the variables. In other words, we're going to determine the greatest common factor for the variables of each term. Okay, so let's go ahead and work the first variable, which is x to the fifth. And we find that x to the fifth is actually x times x times x times x times x. Okay, so that's 5 x's. And then for the next variable, which is x to the fourth, that breaks down into x times x times x times x, 4 x's. And then lastly, we have x cubed, and that breaks down to x times x times x. Okay, so looking across all three variables, we see that there are 3 x's here. There are also 3 x's here and 3 x's here. So let's go ahead and highlight that. 3 x's, 3 x's, and 3 x's. Okay, so then what we find is that the greatest common factor is equal to 2x cubed. Okay, 2x cubed. Where did we get the 2? We got the 2 from the prime factorization with the coefficients, and then we got x cubed from finding the greatest common factor for the variables. Okay, so as promised, let's go ahead and work out a second example where there are negative numbers involved. So here we have a negative 18y to the fourth plus 6y cubed plus 24y squared. So let's go ahead and start with negative 18. We have negative 18, and when we're dealing with a negative number, especially when the leading coefficient is negative, we want to factor out a negative 1, okay? So here's what we're going to do. We're going to factor out a negative 1. This becomes positive when we do that. And now we work with a positive 18, and that factors out to 2 times 9. Okay? Now, all of these numbers are prime numbers with the exception of 9, and so 9 can be factored out into 3 times 3. Okay? So bringing all of these numbers down, we see that the prime factorization for positive 18 is 2 times 3 times 3. We're going to leave the negative 1 out here for just a minute and come back to that at the end. Okay, so now we're going to take the coefficient of 6 and write it out here. Okay, now because we took out a negative 1 here, we have to do that across all 3 coefficients. Okay, so we're going to put a negative 1 out here, and when we do, we have to change the sign of the coefficient. So then we look at 6 and discover that the factors of 6 are 2 times 3. So then our prime factorization for negative 6 is negative 1 times 2 times 3. And then lastly, we have 24, and we have to do the same for 24 as we did for 6, and include the negative 1 as one of our prime factors. And when we do that, we have to negate negative 24. And now we work the other factors by looking at 24 as a positive number and discover that 24 breaks down into a number of different factors. We're going to use 2 times 12. Okay? Negative 1 and 2 are both prime numbers, so those can not be factored any further. However, 12 can, and 12 factors into 3 times 4, and then it factors further down, at least for 4, to 2 times 2. Okay, so if we carry all of these down, we see that the prime factorization for positive 24 is 2 times 3 times 2 times 2. Okay, so now we look at what's common across all 3 of these coefficients, and we see that obviously negative 1 is common across all 3. We also have a 2 that is common across all 3. And we have a 3 that is also common across all 3. So what we find is that our common factor, or greatest common factor for just the coefficients, is negative 1 times 2 times 3, or negative 6. Okay, so that's step 1. Step 2 is look for the greatest common factor of the variables. So let's go ahead and do that. So in looking at the first variable, we see that it is y to the 4th. And so y to the 4th breaks down to y times y times y times y, or 4y's. And then the next variable is y cubed, and y cubed breaks down to y times y times y, or 3y's. And then the last is y squared, and y squared breaks down into y times y. Now what we see is that there are two y's over here. We also have two y's over here, and we have two y's over here. Okay, so then the greatest common factor for the variables is y squared. So bringing all this together, we're going to take our negative 6 that we found in step 1 and our y squared in step 2 and say that our greatest common factor is equal to negative 6y squared. So if we were to complete this, we would say that by factoring out negative 6y squared, the remaining part of this polynomial would turn out to be 3y squared minus y minus 4. And how did I get that? If you take a look, if we were to multiply this negative 6y squared with 3y squared, this would be negative 18y to the 4th, which is exactly what we started out with. And then if we were to multiply negative 6y squared by negative y, we would get 6y cubed. And then if we were to multiply negative 6y squared by negative 4, we would get positive 24y squared. Now, one thing to note, if you take a look, you see how these signs changed? This is now positive, negative, negative, whereas what we started out with was negative, positive, positive. And if you recall from step 2, we changed, step 1 of this problem, we changed these signs, right? When we take out a negative, this becomes positive. When we take out a negative, this comes out negative. And when we take out a negative, this comes out negative. So all of the signs change. So if you take a look, you see that this is now positive, negative, negative. And that's exactly what we have here. Positive, negative, negative. So what you'll see is that the reason it is helpful to factor out the greatest common factor from a polynomial is because when you do that, it results in a polynomial with smaller coefficients, right? So we've got 3, negative 1, and negative 4 is smaller coefficients. And this makes it easier to either analyze the polynomial or factor it further. Okay, so there were a lot of moving parts there, and you may have been confused the first time through. If this was not clear, as always, please go back to the beginning of the video and listen to it again. Thank you.